Hi, I'm Ethan Wagner.
Hi, I'm Sion Chand.
Hi, I'm Holly Lee.
Hi, I'm Matthew Kelly, and we're
We're
the
Simple Machines.
So our mechanical music maker was based on a music box design. So these erasers, when spun, hit pre-tuned metal strips, making a note that's either C, D, E, F, G, or A. It's fully mechanically powered. It uses a hand crank as the power source. All the materials are safe. We used wood, brass, PVC, erasers, metal screws, all safe materials. It fits within the 3x3x3 cube requirement. It's only about 2 feet on this axis and a foot to a foot and a half on this axis. It doesn't use any electronics. And the music, as just demonstrated, plays between 10 seconds and 1 minute, meeting the music length requirement.
Okay, so we had several difficulties when making the mechanical music maker. The first of which was probably the volume. It's not the loudest thing in the world, and at FEDD, it was, I'd say, barely audible over the noise of the room, so that was definitely a challenge. In terms of the notes, we had some trouble tuning them using the screws and using the metal tines because the length, like between each note on the tine, was actually really short, and so if we didn't cut it exactly right, it wouldn't work at the note that we wanted it to. The sound quality also we had some troubles with. At first we used just bare screws on the tines, and that kind of produced a scratching sound that was pretty unpleasant. So the erasers kind of mute the scratching and produce a better sound quality, but they're also kind of a little bit too flexible at times and can tend to break. So the sturdiness was definitely an issue there. Last of all, probably just the size of the PVC was maybe a little bit too small to allow for an adequate spacing between the notes. So instead of like a clear bell sound at each note, when you have notes grouped together, you kind of get like a ticking sound in between them instead of distinct notes.
Okay, so if we could start over again, I think we would choose a better song with less consecutive notes because, as Ethan said, consecutive notes make the notes have a clicking sound between them. And we would drill holes in every spot of the PVC so that the music machine would become customizable. And we would also get a bigger PVC if we have a larger budget because this PVC the circumference is so small that the notes wouldn't fit on them. Like this one, we had to do 2/3 of the verses so that all the notes could fit on them and not create a worse sound. We would also use a different metal for the notes because brass is a soft metal, and when hitting with the razor, it kind of creates like a very soft sound instead of what it could be louder. Okay, we would also use a different material for plucking, such as maybe wood or plastic instead of these really soft erasers, which makes the volume kind of small. And we would also make a better plan for construction because we kind of just went in and screwed everything in without realizing, oh, maybe later we have to unscrew something in order to put the stick in or stuff like that.
Right, so I think one of the biggest things we learned about was the engineering design cycle. So we started off with like a problem given to us, and we had to basically figure out what constraints we had on our project in terms of like how much money we could spend on it, what kinds of construction we could do. And then we had to start brainstorming possible ideas. I think we went through like string instruments, wind instruments, and we decided on a percussive instrument because that was like the easiest to control. And then we had to kind of like plan out how we were gonna basically finish this project over the course of the semester, plan out meeting times and figuring out what needs to be done by when, setting deadlines for ourselves. And then obviously there's the whole construction part of it, which was a learning experience in of itself, working with like the craft center at NC State and just figuring out how to like work as a team to build this thing. And then finally, after we like built our first like final project, we had to test it and improve it, fix any problems we found with it. I think that was one of the biggest learning opportunities we had.
Overall, we don't think that we did too bad because we went over the whole engineering design cycle, and we started off pretty early, and we were working each week consecutively. Yeah.
We're definitely excited to have the opportunity to present at FEDD and compete with other groups. It's very cool seeing all the other projects.
I think we definitely learned a lot about engineering, as we talked about, but also about teamwork and just finding solutions to tough problems that you might not see how to solve at first.
So I'd say overall, the FED project throughout the semester was a success.
Yay!